welcome back to the channel. Today we are taking one of the most popular system design interviews questions about how to design a scalable, real-time chat application like Facebook Messengers. Whether you are preparing for your interviews or just curious about how these apps works under the hood, this deep dive will have you covered. So let's try to jump into it. And if you have been in a system design interview before, I guess you are familiar of the famous framework of trying to understand the problem. After that, trying to propose a high-level design, we go to the deep dive, and in the end, we just talk about some sort of how to improve some sort of improvements for the system. So we will use this framework, and I will advise anyone to use the same framework for your system design interviews. So the first thing you have to do when you've been asked any question to design a system, to ask first what. Basically, what is system? So if you don't know what a Facebook Messenger, or if you haven't even used a Messenger chat app in your life, so first try to understand and answer the question, what is a Facebook Messenger, or what is a chat application? A chat application, it's basically kind of software products or software apps that helps user A and user B to send message to each other, like send, receive messages, and maybe get like a read and delivered receipts, so they know the message has been read or delivered or whatever it will be. So this is the answer for the what. So when you know the what, you need to go to the next level. The next level is to try to understand what is the functional requirements and the non-functional requirements. And you always start with the functional requirements of your system. So the uh, fun- functional, let's call it Rick. Yeah, the functional requirements. And in the functional requirements, I would say in any system design interview, you need to add like maybe from 4 to 6, not more than that, because you will not have that much time to add all of this information, and not less than that. So your interviewers will think that you don't know what actually you're talking about. So if in the functional requirements we say that uh, we support one-to-one conversations, maybe we could support a group, but we will look about that. Let's add support a group as well. Support a group messages, conversations as well. Also, we need to keep track of online offline status, like keep track of of online and offline. Also, we need to support multimedia messages, like images, something like that. Support media messages like uh, photos and videos and audio as well. Um, okay, let's make this wider. Okay. I guess we can add one more. It's to add like some sort of push notification. So basically, when you got a new notification, a new message, you'll be able to, like, the application will send you, hey, you got a new something. So we need to add push notifications for new messages, calls, and mentions. So this is the function requirements, and I guess we are good at this point. I would say that in any system design interview, please, 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 please do not assume anything. Just to try to make a conversation with the interviewer and ask, okay, did we finish? Does this seems good? Do we need to add any other requirement? And for each requirement, you ask him, okay, I guess our application needs to support one-to-one applications, not one-to-one chat. You said, yeah. So you add the point, and you said also we should support the group chat. You said, yeah. So you add it. So like, think in your systems and interview as it's a process and a journey, and a problem that you and your interviewer will have to fix it together. Okay, so let's start next in adding the non-functional requirement. Non-functional Rick, and I would say let's add the first thing. I guess we need to have a real time message. So we need to have very low latency. Real-time messages like delivered with minimal latency. Like we need to have very very low latency. We need to have the ability to handle like millions of concurrent users, concurrent users, concurrent users. Um, we need to have high availability. Availability. I guess I mispronounced availability. That's okay. Although consistency can take precedence in certain cases, so we can have like tunable consistency or like yeah, something like that. We need to have durability as well. Durability to make sure that messages aren't lost. Okay, so right now we have our functional requirements and we have our non-functional requirements. What should be next? The next thing we should do, we call a capacity estimation. Capacity estimation, it's basically let's just put no capacity estimation. Capacity estimation. Okay. This is great. Okay. A capacity estimation, it's basically when you try to understand how our application will behave and basically what is the capacity of our system. So let's assume in the capacity estimation we will have like a total amount of assume like we have 1 billion user, and we have around maybe 500 million daily active user. Um, at peak concurrent connections, we maybe have like 50 million users connected at peak times. This at peak, 50 million user at peak. Um, we could also talk about in we can make talk about capacity estimation for the storage. So we can the daily storage. Let's assume that the message is 1 kilobyte, and we have about 5 billion messages per day. I guess this 5 billion messages, and so basically we have a daily five terabyte. So annual storage will be it will be 5 terabyte multiplied by 30 to 165. It will be maybe you have like 101.8 betabytes. Okay, we can talk about, I guess, bandwidth estimation. So within 10 million users concurrent during peak, we could say we're assuming the average of 10 kilobytes per connection. We have each connection take 10 kilobytes. We would need about 100 gigabytes of bandwidth, for example, to support real-time messaging at peak usage. So, okay, we have done the following. First, we understand our application. We get the functional requirements and non-functional requirements. We did the capacity estimation. Now we need to talk about the high-level design. So we said that we need to create a chat application. So let's assume that we have, what is this? And make it like that. And maybe we can add like 2 users. Like I said, user 1. And let's call user A and B. Let's call user 1 and user 2. Yeah. And we have user 2. Okay, so we need to create an application that help user one to chat with user two. Okay, so first we will have user one and user two will try to send the requests to a load balancer, and they will communicate using a WebSocket. And WebSocket, oh, sorry, okay. And a WebSocket, it's basically a bi-directional way of communication. So let's try to understand why we're using a WebSocket. So first, let's add um our uh, our load balancer. So let's call it B. So because we need when user one send the message, we need our applications to be able to send the message to user two. So in order to make the applications have the ability to send the messages to user two, we need to have one of two solutions. First, to use like a WebSockets. WebSockets bidirectional. It's connection bidirectional. So basically, the connection will be established between the user and the load balancer, and the user and the application, and both of them can send requests, or we can have what we call polling. And polling basically will means, or long polling means basically the user two, for example, would try to send a request like in periodic time. So it try to send requests, one request per second. So it will try to ask the server, do we have a new information? Do we have a new information? Do we have a new information? And whenever the load balancer have any information, it will send it back with the information. If the load balancer doesn't have any information, it will send the answer no. So basically, this is how it works. But we need a real-time messaging. So because of that, we will use a WebSocket. So let's just delete everything, and we will have a WebSocket connection between this. Can I make it bi-directional? Um, uh, no. Okay. This way. Okay, it works. And let's make it WebSocket. WebSocket. Ah, because both of them are on top of each other. Okay, so we have again here another WebSocket connection. WebSocket. WebSocket. So we told that the connection is a WebSocket connection because we need basically our users to our users to have the ability to get the data from the server without requesting it. So we need to give our application the ability to send the data directly to the users. So because of that, we're using WebSockets. Then next, okay, and we're using load balancer because the load balancer distribute incoming traffic across multiple chat servers, ensuring even load distribution and prevent any single server from being overwhelmed. It supports sticky sessions using IP hashing to route users constantly to the same server. The next we have a chat servers. So no, let's make this one like that as well, and make it quite wide. Okay. Um. Oh no, it's big. This one's really big. Chat server one. Okay. Oh, okay. Let's make this like that. Uh, And we have like a chat server two. No, 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 no. What is this? Copy this. Chat server two. And let's make it smaller because our application will have multiple things. So we need to be quite wise when we choose. Let's be close. So the load balancer will be connected with the chat servers as well. What's this? No, will be connected with the chat server using WebSocket as well. WebSocket, and here as well WebSocket. Okay. Next, we need to have a user connection cache. Let's first talk about the chat servers. Why it's like that? Um, anyway, I guess it's this is look better even. Let's talk about the chat servers. These servers handle real-time communication with WebSockets. Each chat server maintains persistent connection with the users, facilitating low latency message exchange. And we need to have a user cache connection because a fast in-memory cache like Redis keep tracks of active users' connections and their corresponding chat servers. It also stores user status like online, offline, and last seen messages. So we need to have like let's call it like a user cache connection. Connection. And let's make it with this one real small and make it like here. And we can make it bigger. Yeah. So user cache connection. Let's put here. And next we need to have a notification service. And I guess we can make the notification service a third party because there is no need to basically why it's not pointing. Wait a minute. No, I need to make this one pointing. No. Yeah. No. Like that. Oh. And that's exactly. No, the way around. Okay. Next, we need to talk about the notification service because it's quite important to have a notification service, and it was in our notification service. And let's make it like that, and make the font really okay. In terms of the notification service, for users who are offline, the notification service sends push notifications for new messages or events. It integrates with externals provide like Firebase Cloud Messaging, like FCM, or Apple Push Notification Service. I guess it's a good idea to use a third party because we don't have to build another system only for notification. Because right now, we need to focus ourselves on the yeah on only let's I guess this is looks better. Okay, this is looks great now. Next we need to talk about um how will we store the messages. So the first thing I would like to think about is to using a message queue. Let's make it a message queue, and I like to make it this and wider. Um, Message queue. Okay, we have message queue, and this message queue, like a distributed message queue such as Kafka decouples messages processing from real-time chat. Messages are temporarily stored here before being processed into database or sent to the offline. Because in the non-functional requirements, we said that we need to make sure that our messages will not be lost, basically. Okay, so let's talk about what we add next, which will be the message service storage, and this one is quite big to talk about. Let's make it like that, and I need to make it. Let's make it a normal one. Message storage service, and No. What? That. Yeah, please be here. And I would say also we have a message DB, multiple message DBs. Okay, so the message service, this component handles the durable storage of chat messages. Messages are consumed from the message queues and written to NoSQL database like Cassandra for fast retrieval and scalability. So we use NoSQL because we have hundreds and billions and billions of messages. And we did talk about the media service, and we did talk about that we should have a message group. So let's just try to add these two things. So in the chat server, we can add let me add like some, no. Yeah. Let's add here like a group service. I don't know why everything is so big. A group service, and this group service should be connected with group DB. Okay. And yeah, the group DB. Yep. And I guess we need to talk about how we will handle the media messages. The media messages, it will be, I guess, quite simple. In the message service, for example, each message, let's say that it's an image or something, it will be have like the link of each message and something like that. And in the meanwhile, we could have like to handle messages, we could have like a media service. This media service should be and this media service should be connected with like a blob storage, like it's a 3 or something like that. A blob storage is short for binary large object, and also because we said that we need everything to be quite as fast as possible, and also to improve the user experience and reduce the latency, we'll use a CDN. The CDN basically will try to cache any assets data like images, videos, stuff like that, to the position which is closer to the user. And this is the full system, and I guess it looks quite good. I'm pretty proud of myself that I could pull all of this. So let's talk about the media service. The media service process and stores multimedia files like images, videos, and documents. Files are uploaded to cloud-based object storage solutions like Amazon S3 for scalability and durability. In terms of the group service, this manages group conversations, including group membership rules and settings. It interfaces with the group DB, which stores metadata for all groups. We have the content delivery network. The content delivery network. Basically, to ensure quick access to multiple files, the system leverage a CDN to store copies of files closer to users' geographical location. This minimizes latency and improves the user experience. So the system uses a combinations of SQL and NoSQL databases here. In terms of database, like users and group metadata are stored in a relational database like Postgres, while chat messages are stored in NoSQL database like Cassandra for high write throughput. I would say, yeah, that's that's I guess that's most of what we want to talk about. We might talk about some things in the deep dive, like WebSockets are the backbone of real-time messaging, unlike traditional HTTP. We talked about that. Which require repeated handshakes. WebSockets maintain a persistent connection between the client and the server. This reduces overhead and allows seamless bidirectional communication. And in terms of the real-time messages, like when a user sends a message, it's transmitted via WebSocket to their connected chat server. The server checks the user connection cache to locate the recipient's service. If the recipient is online, the message is forwarded to it instantly. Otherwise, it is sent to the notification service and stored in the message queue for later retrieval. Um, the messages status like send, deliver, and read are updated in real time using acknowledgement between clients and servers. For instance, a read acknowledgement is triggered when the recipient opens the message, which then updates the sender's app. Um, in terms of the improving our system, like scalability and resilience are crucial for handling millions of concurrent users. So we can expose how we achieve this, where users and messages data are partitioned across multiple shards and distributes to distribute the load. Replications ensure high availability as well, allowing the system to recover quickly from server failures. If a chat server fails, clients automatically reconnect to a healthy server. The load balancer ensures seamless redirection, minimizing disruptions to user experience. Um, so yeah, that's the main thing, and I hope you like my video. I didn't do any database schema. I don't know if it's necessary for you guys. I only want to focus on the system on high level. If I forgot any important component, please tell me in the comment section below. And if you have any improvement for the system, please give me a comment to the next give me an like an information in the comment section below, and I will review it, and I will create a new video, for example, and I'll just say a shout out for you, and we'll try to read you the video to make sure the application that we're creating is the best application possible. So that's it for this video, and see you in the future, guys.